Shortly after I created my YouTube channel, I created a video series on how to build a full network using OPNsense. I based that video series off of a written guide that I did on my website, and that guide was actually somewhat geared towards more intermediate level users, because I was just kind of pulling together a bunch of concepts that I had on my website that I've written about over the years, and I wanted to show it all in one big guide just to show how everything works together, because sometimes when you see small little pieces of different topics, and it's hard to put them all together and have a fully functioning network. So I thought that would be a helpful guide for people, and it seems pretty well received. But I didn't go into a lot of detail, like especially when it comes to link aggregation, if you actually need it or not. So there's a lot of users that are just creating link aggregations whether they know they needed it or not. And I know with 1 gigabit interfaces, it's definitely easy to saturate interfaces. Most home users are probably not going to be saturating their network very often if you're just streaming data and you don't have any servers or any NASs or whatever on your network. You're not transferring a lot of data between networks. So link aggregation might have a little less of a benefit for many users. So there's different topics like that kind of I didn't clarify in a lot of detail. So I'm going to leave a lot of those types of topics out in this video, and I'm going to do a more simplified version of that guide. I actually already have it on my website, and I'll link to it below. But this will be the video version of that, and I'm hoping to do it all in one video because it's actually that much more simplified that I can actually fit it all in one video. And hopefully it'll be a little bit less overwhelming if you're new to OPNsense, because I know sometimes that bigger guide trips a lot of people up in certain areas because it's just a lot of concepts all at once. I'm still going to have to assume some basic level of networking, because if I took the time to stop to explain like what is an IP address and a MAC address and different various networking concepts, we would get so bogged down in all those details that we would miss the overarching concept of how to set up the full network. And there's a lot of different other topics about you can do multi-homing and stuff with your devices so you're not using a lot of bandwidth across networks, which I do briefly touch on in my written guide, and I might mention it later in my video as well. But those are just little topics you can kind of branch out once you get your main network set up, and this is going to just be about the network architecture. So I'm going to assume you have hardware such as the Protectly VP2420, which I'm going to be using in this example, and I'm going to be using the network switch such as the TP-Link T1500G -10 MPS, which is just an 8-port PoE switch. It's managed. I'm going to be using a Grandstream wireless access point, which supports VLANs. So all of my hardware supports VLANs. So it's kind of similar to my other guide where I have 3 devices that I'm setting up for the network architecture. I'm just going to make the architecture a little more simple because we're just going to only have, in this example, 2 networks. We're going to have 1 physical network and 1 virtual network, 1 VLAN. So let's get started. All right, so now let's configure OPNsense. You could use the default IP address of 192.168.1.1, or you can use OPNsense.local host name. I like to use the IP address because if we change the host name, we don't have to change it in our browser and potentially sign back in. So let's just use the IP address, which I already have it typed in up here. And this will bring up the OPNsense interface here. We just have to accept the risk because it's a self-signed certificate. And as you can tell, I already have signed in before. So as you can see, the wizard will pop up, the initial configuration. After a few seconds, it'll go to the general setup. Instead of going through the wizard, I'm going to show you how to configure OPNsense with the normal menu options so you know where they're located at instead of going through the wizard, because all the options that are in the wizard are actually in OPNsense. They just put them together in a nice little format there for you to set up if you want to go through the wizard. For beginners, it might be nice just to walk through that wizard, but I just want to show you where they're actually located because that's where you'll be tweaking that stuff later when you actually need to make changes. So if you click on the logo in the upper left-hand corner, it'll take you to the dashboard, which is under the lobby menu. So you have all these different default widgets here displayed, and it shows all the services that are running and the gateways and the interfaces, and as well as some system information here of CPU usage and RAM usage. As you can see, RAM usage on OPNsense is actually pretty low when you don't have anything running. Right out of the box, it's using 715 megabytes of RAM, and 183 is actually arc size for ZFS. So if you're using ZFS uses a lot more memory, which is fine if you got plenty of memory. So let's go to system settings general. This is where a lot of the settings are in the wizard page. A lot of them are here, located here. You can give your router a host name and a domain name. The domain name is used for your entire network, not just for OPNsense. So anytime you want to access a local client, you can just use most of the time the host name. But if you want to use the fully qualified domain name, FQDN, right, you can actually type in like OPNsense.local domain, and you can get to this OPNsense web interface if you have it allowed via firewall rules or whatever. But if you want something different here, like I can put in homenetworkguy.com, right? Because I own that. Preferably, if you own the domain name, you can put it in here, or you can make up one that doesn't exist on the internet. Just make sure you don't pick one that actually exists, because your DNS will resolve to your local domain name. Might get confused with real ones. So we can call this router if you want, right? router.homenetworkguy.com. So you can make that whatever you want. You can pick your time zone that you're in. It sets it to UTC by default. And there's different themes here that you can install, but you have to go to the plugins page and install that, because a lot of people like dark themes, and you can actually download a couple different versions of dark themes for OPNsense, which is nice. Okay, so down here in the networking section, you can put DNS servers in here if you want. This is DNS servers that are used by the system, which is OPNsense itself. Okay, out of the box, you can leave these alone, because in this example, I'm not going to show a more advanced DNS configuration since this is a beginner's guide. So I'm going to leave this stuff as a default, because out of the box, this allow DNS server to be overridden by DHCP on the WAN interface will basically allow you to use your internet provider's DNS service, which is a good way just to get started. And then once you get that working and you know your network is functioning properly, then you can maybe uncheck this, and you can set up some other DNS options that I've went over before in other guides on my website, and some of my other videos potentially will have some of this information as well if you want to go to more advanced DNS. So for now, we're just going to leave all these things, and then you can hit save when you're done. For the administration page, there might be a few settings here you might want to change. Out of the box, it's using a self-signed certificate. You can enable strict security transport protocol that help prevent potential malicious users from trying to hack, and take over your HTTPS sessions and stuff like that. It's probably not a super high priority for home users if you're not exposing it to the internet especially, but it could be helpful, for something bad on your network. It could help that enable some of these features. Let's see if there's anything else here. DNS rebinding can cause problems sometimes if you're trying to access certain services on your local network, but I don't like to disable them, because that's actually a good security check to have. There's other ways around this. You can enter alternate host names here that will be ignored for DNS rebinding. I know Plex uses like plex.direct as a domain host name that sometimes DNS rebinding might interfere with. So we have some HTTP compression settings here. You can enable these. Most boxes are probably fast enough, you can probably enable this. And I don't know if it really speeds up the web pages that much. This could be helpful if you want to connect remotely, hopefully over a VPN, not open to the world. But if you want the web pages to be as small as possible, this compression can maybe help speed it up just a little bit when you're trying to access pages remotely. The listen interfaces, I sometimes will set this to just one network that I want to manage OPNsense from, but since I'm only going to create 2 separate networks for this, I may recommend just setting this to the LAN network once we're done. But we want to make sure we get everything set up first. So you can always go back and just only allow it to be on the LAN network, because that's going to be our trusted network, and then that way you can disallow access to your OPNsense from your untrusted network, so as you don't want people trying to log into OPNsense, right? So that might be a good option to set once you know everything is working. So let's go down here. You can enable SSH. I'm not going to show how to do these types of things, because I'm just assuming that most beginners are just going to use the web interface, but you can log in if you know what SSH is to get a secure shell into OPNsense, so you can use command line. That's sometimes helpful. So that's pretty much it for those options. So let's go to miscellaneous. One of the things you might want to set here is your thermal sensors. I'm using an Intel processor. If you want to show your CPU temperatures in a widget on the dashboard, you definitely need to select this hardware here for thermal sensors, because otherwise it will not show your temperatures, or at least not properly. So you definitely need to select that. I think it's helpful especially for many PCs that are fanless to have this temperature displayed. So we'll go ahead and set that. So if we go down to power savings, you can actually set this to different options here. I think it's actually by default using high adaptive, but it's not actually enabled. So if you click this checkbox, you can enable this, because high adaptive, this allows it to be the maximum performance, and it helps regulate like the CPU core speeds and stuff like that to help boost performance or even limit performance if you're worried about temperatures. So there's some other options for disk usage and stuff. You can do like RAM disks and stuff like that for logging. This is really useful if you don't have like an SSD or something and you're trying to put it on a system. It's using like I don't know, micro SD or some kind of crazy storage. It's actually not very reliable. You definitely want to make use of some of this RAM disks for logs, but if you do that, you'll lose them, of course, when you reboot. So we can just hit save on this, because I actually do want to have this enabled. So I'll show you real quick, since we just enabled this option. If we go back to the lobby and the dashboard here, and we can add a widget, and we will add thermal sensors. So we'll close that out, hit save, and then all of a sudden you got CPU temperature sensors here. Since I picked Intel, you can actually see that there's my core temperatures. All right, now let's look at interfaces and what we need to do to configure that. So let's go over to interfaces and go to assignments. I have a 4-port mini PC, which I mentioned earlier, which is the Protectly VP2420. And I have only 2 interfaces assigned. One's for the WAN interface and one's for the LAN interface. As you can see, I actually swapped these 2 interfaces. I did that when I did the initial installation, because by default, the WAN would be IGC1 and the LAN would be IGC0. But I like to have the WAN interface on either the far left or the far right, depending on how my connections are. I don't know if I just prefer that because I used to use consumer grade routers and they always had the WAN interface off to one side, but this is really a preference. It doesn't have to be this way. I just want to let you know that you might see this reversed if you just left it at the default installation. I mentioned this in the written guide, how to switch these. So you can actually do this from the console if you want, before you actually log in. So when you plug in, you're in the proper interface. And you can actually do that by going to the console and doing option 1 and then reassigning their interfaces, which I'll have a video overlay here to show you that process as I'm discussing it right now. And so, but an alternate way of doing it is that you can actually come in here and swap your interfaces from the web interface. The bad part about doing it through the web interface is you'll get disconnected and you'll have to physically move your connection over to the other port after you save these changes and then log back in again potentially. So it's more disruptive to do it through the web browser. That's why I would prefer to do it during the installation or at the console command line. And then you can just swap those interfaces. So you'll see that I actually have 2 other interfaces that I don't have assigned to anything. In this guide, I'm actually not going to use either one of those interfaces. I'm just going to use the LAN interface, and we're going to add a VLAN. So even though I could actually make use of 2 different networks with 2 different interfaces, I actually just want to put one VLAN on one of these physical interfaces, the LAN interface, just as a demonstration to show how to set up VLANs. I want to show at least the concept of how to set up your first VLAN, and then you can add more later if you want. So to set up VLANs, we actually can't do it from here. We actually need to go to other types, and then we'll go to VLAN. So we got to set up our VLANs before we can assign them, because the LAN interface is already good. So we just click add over here, and then the parent interface, remember we said will be the LAN, because remember virtual networks have to reside on top of physical networks. So a virtual LAN is actually just a logical network on top of a physical network. So let's make this VLAN tag 10, and we'll just leave it at the best effort. I'm not sure how much the VLAN priority affects performance. It's supposed to give priority based on what you select here. But best effort's fine for our purposes. We can call this untrusted, because that's going to be our untrusted VLAN. And let's hit apply. Okay, once we hit apply, we actually just go back over to assignments. So when we go back to the assignments page, you can actually see that we now have a VLAN in here that you can actually assign as the untrusted VLAN, and the parent interface is IGC1. So let's pick that. The description is already set from what we had before for the VLAN, which that's what we want, which is nice that pre-fills that. It didn't used to do that. I think that's a newer feature. And we'll just hit the add button, okay? And then we hit save. So you don't want to hit save because you have to add it first, and you'll notice it pops up in here in the list, and then you hit save. Now that you hit save, you'll see that the interface now appears over in the left-hand menu as untrusted. So we just need to enable this interface. I like to prevent interface removal. This keeps you from accidentally deleting the interface out. So it's kind of a nice extra measure to make sure you're not deleting this out. And for the IPv4, we're going to set up a static IPv4 address for the interface itself, but it also gives us an IP address range for your network. So this is kind of interesting. You can think of an interface as your gateway to a whole entire network. So the IP address at the bottom here we're setting up is actually for the interface itself. We're going to set it up as 192.168.10.1. I always like to make the interfaces .1. You don't have to, but that's kind of a convention a lot of people use. And for this, this is the CIDR notation. So we want to pick 24. This is what creates the size of our network. So 24 just means this last octet of the 4 octets that we have in our IP address. That last octet is how many IP addresses you can use. And in that last octet for IPv4 addresses, you get from .2 to .254, because .0 and .255 are reserved for network purposes, and .1 is used by interface. So we get 2 to 254 is our total range that we get for this interface. So we hit save and we apply changes. I'm not going to mess with IPv6 configuration in this guide, but I have went over that in other guides. So that way we don't get bogged down in details. We'll just get an IPv4 network set up. And then if you want to explore IPv6 later, that's something you can do. So now let's go to the services, DHCPv4, and then click on the untrusted network. We need to set up DHCP for the network, so then you get automatic IP address assignments, which you definitely will want on your network. So click on the enable, and then we can select this range here if you want to copy and paste, so you don't have to type as much. So, I'm just going to set an example range of just 100 IP addresses. You can actually change this if you want. So I'm just going to do 100 to 200. I recommend leaving a little bit of the space available if you want to use static IP addresses, because they need to be outside of this range. So I wouldn't go from, it says you can use 1 to 254, but you can't use 1 because that's the interface. But you can go from 2 to 254. So I don't recommend putting that full range in here unless you don't plan to have any static IP addresses, because if you have servers and stuff, you might want to have some static IPs. So let's scroll down and hit save. Now we have DHCP enabled on the network. And for DNS, so I'm going to look at DNS real quick and go to general settings. By default, it's enabled on all interfaces, which is what you want. This makes it easy. Some of the settings I recommend you do, since we're trying to keep DNS simple for this example, is just register DHCP leases and DHCP static mappings. If you register these, whenever you have a DHCP client or a static mapping defined for a client on your network, you can actually just access it by the host name, and Unbound DNS will know exactly what IP address it is for those clients. So it's handy to have this, so you don't always have to type IP addresses for all your devices to access them. So I like having those enabled. And the only other thing is I think it's good to have is flush DNS cache during reload. You don't have to do this, but to me, it's helpful, because if you're making any DNS changes on your network and you have to restart the service, or changes get applied or whatever, I really like having it clear this stuff out, because stuff gets kind of stuck in there, like old IP addresses associated to certain host names and stuff like that. So I like having this flushed, because it kind of helps make things happen quicker. And you might lose a little bit of DNS performance until everything is cached again, but on a local network, you're not going to notice that speed difference too bad, I don't think. So you might have a little bit of an issue there, but that, for the most part, is helpful when you're making changes. When you're not making any changes, this has no really effect until you're reloading the service. So that's it, apply changes. So one last thing we need to do is configure firewall rules, because this will isolate your two networks from each other, so then nothing can access anything between the two networks. So you have completely separate networks, so your untrusted devices cannot reach into and get access to your trusted devices. Let's go ahead and go to firewall and go to aliases. So the first thing we want to do, we're going to create a private network alias, because this is important to help isolate networks. When you only have 2 networks, you don't have to go this route, but if you're adding several VLANs and interface networks and stuff, I like just blocking all the entire private IP address ranges, because it actually just helps you not forget in the future to add in new networks every time to your firewall rules when you add a new network, so you can potentially leave something wide open without realizing it. And so it actually is a little bit less secure. So I feel like this way you're blocking everything by default, and then you have to go in and allow specific access. So it's safer to do it this way. That's why I prefer to do it this way. So I'm going to show you this real quick. So we're going to call this private networks. And then it's just going to be networks as our type. For content, we're going to do 10.0.0.0/8, and then hit comma, and then it'll make that box around it, and then we'll do 172.16.0.0/12, and then comma, and then we'll do the last range, 192.168.1.0.0/16, right? And then we'll click description down here, and we'll say RFC 1918 private IP address ranges. Okay, you can put whatever you want for the description. It's good to be to describe these things, and hit apply. So then this alias can be used in your firewall rules. The reason we're creating an alias, it allows us to select multiple values in a firewall rule, because by default you can only select one value, whether it's an IP address or a network range. You only get one value you can enter in each firewall rule. But if you create an alias, you can have as many values as you want in the content here, and you only have to refer to a single alias inside your firewall rule. So I'll show you how that works once we get down here to the rules. Let's go to LAN first. By default, everything's wide open. You get access from LAN as the source to allow any. So it's going to allow access to all your networks, including the internet. So what we're going to do, since we're not doing IPv6 in this configuration guide, we'll just delete this one. What we'll do is we'll actually just edit this. In my written guide, I just said delete it just so you don't get confused with the configuration. But since I'm showing you visually, I think it's fine if I just edit this existing one just to show you what you need to do to change this to make it a little bit more restrictive. Because right now we're going to be allowing access to our untrusted network from LAN, which you might want to do, but I think it's still good to kind of keep the networks isolated so you're not reaching out to your untrusted devices from your trusted network in case there's something malicious happening from your trusted network, right? If something bad gets in there, right? So we'll just go ahead and isolate this. So right now, the only thing we really need to do, our destination is going to be inverted, okay? And our destination is actually, we're going to pick our private IP addresses, private networks. Yeah, and then we're going to change our description to say this is going to allow access to the internet, but block access to private networks. So I wanted to describe this real quick because I've mentioned this in other guides before, and my written content. But this destination invert means not. So basically, when the destination is not a private network, then it'll allow it, because this is a pass rule, as you can see at the top. So that's when you have this box checked, it's very important. We're basically saying anything that's not a private network, allow that connection. So anything that's not private is what? Public, right? So that would be the internet. So we're basically allowing only the internet with this one simple rule. With this one simple rule, we're allowing access to the internet. But we need to add one more rule after this. So we'll hit save, and I'll show you what we need to do. Okay. Let's not hit apply changes until we're done, because you'll start blocking things you don't want to block here. Okay, so let's add one more rule here. We want this to be on pass, and we want the protocol to be TCP to be is fine, and we want the source to be LANnet, because that's our network that we're in, and we want the destination to be a LAN address, and the destination port, just pick DNS. So what we're going to type here for description is allow access to DNS server on LAN interface, because the rule that we just added will block all the private IP addresses, which includes the interface itself, because once the traffic starts to leave the LAN network and hits the LAN interface, that firewall rule will block anything, even on the LAN interface. So you're going to end up blocking DNS on your server. This is a consequence of blocking all private IP addresses instead of just blocking only the other networks. So you could do that. We could just block untrusted network if we wanted to, right? But I like this private IP address. You know, it requires one extra rule here at the top. So we need to actually click this box and move it up here. So we want to have these two rules. So then we're allowing, then we can hit apply now. So we want to allow access to the DNS server on the LAN address, which is your interface address. And then we want to allow access to the internet. If you follow this same pattern for each of your interfaces, then you automatically get isolation, and it only requires two rules. So it's actually, one way you can do it. It's not the only way. You could make this a single rule, but you'd have to keep adding in your new networks, right, every time you make an update. So to avoid that, you just do it like this. So what we need to do now is go to the untrusted network. So as you can see, if we go here, when you create any new interface and new network, it actually has no rules by default, which means everything's blocked by default. So if you just want a complete isolated network that doesn't have access to internet or anything else, like for camera, IP cameras on your network, you can actually leave it like this, right? And then you're already isolated. But we want this one to have access to internet just like the other one, but not access to the LAN network. So let's go back to the LAN network. We can actually clone the rule to make it a little bit easier, right? So let's go ahead and clone this first rule. And then what we'll have to do, we have to make sure we change the interface to untrusted, and we want to change the LAN net to untrusted net. And you want this to be LAN address to be untrusted address. And then we can leave everything else the same except for this description, because we are being very specific in our description. So we just make sure we hit save. Okay, and now let's go back to LAN and we can clone the second rule. And we have to pick the untrusted network again. And this one we just pick untrusted net. Okay, and because we actually left a generic description, we don't have to update that. And so as you can see, it actually put this at the top. So what we need to do is we want to make sure our DNS entry is first, so it won't get, so actually will get applied. So we don't want to hit apply changes. So there you have it. That's all you need to do to have completely isolated networks. If you want the untrusted network to reach into your LAN network for something you have hosted there, you can actually go and add a new rule. You just have to make sure it's above this bottom rule. So anytime you add a new rule, you just have to make sure it's above that bottom one, and you should be good to go. You can actually make it access like a specific device on your LAN network if you want, on specific ports. So you're allowing some access, you're still controlling what access is allowed. And so at least it's better than a flat network where everything can have access to everything, as I mentioned before. That's all we need to do for OPNsense. It's actually not too bad to get started out of the box with two separate networks that are completely isolated. So now we're going to configure a network switch next. What I recommend doing is just plugging directly into the network switch first and get it configured, because we need to change the IP address on it usually. And then before we plug that into OPNsense. And then once we plug it in OPNsense, we'll do some tests to make sure everything's good. And then we'll go and configure the access point last. So let's go ahead and go do that and switch over to configuring our switch. So now I'm going to configure a static IP address to configure our network switch. So I know my TP link is in 192.168.0.1. So I'm actually going to configure my devices to be in that same network. So let's go to manual, and I'm going to set my IP address here to be 0.10, just to make it something different than the switch's IP address. And the subnet mask is going to be 255.255.255.0. And then we'll hit apply. Okay, and we'll close that out. Okay, so now I'm going to type my switch's IP address in here, which is, like I mentioned earlier, and hit enter. And now it's going to take me to the TP-Link login page, which takes a second to load. This TP-Link switch's web interface is a little bit slower than some of the other TP-Link switches I have. I'm not sure why, but it doesn't seem like it's a very fast switch interface, but it works. It's not too bad once you get logged in. So it's going to be admin by default. So let's do that. So what we're going to do is, first thing we're going to do is change the system IP, and you can see where I said it's 0.1 here. We actually just want to make this 1.2 because our interface is 1.1. So let's make this 1.2, and we can actually set the gateway if we want. It's not super critical, but for the switch, because it's not really, shouldn't be access to the internet or anything. But we'll set this to 1.1 because that's just going to be our gateway interface, and we'll hit apply. And when we do that, we'll lose access to our page. Okay, so what we're going to do now is actually set our IP address to be in the same network again. So if I go to wired settings and set this up, and all I have to do is just change this to 1 instead of 0 for the IP address, 1.10. And sometimes I just do this just to make sure it applies quicker, because last time it took a few seconds longer than I was expecting. You see how it redirected us to 1.2 already, so I just hit enter on it, and now we're back to the page. The redirect won't work until I change my system's IP address, right? So we gotta accept the risk again. All right. Admin. Let's get back in here. Okay. Now we see if we go back to system IP, it's what we want it to be, because it will now be on the same network as our LAN network. Let's go to L2 features and just set up a VLAN, because this will be pretty simple, straightforward. On our VLAN page, we want to use the 802.1q VLAN. That's the official VLAN protocol. And so if we go to add, notice there's one VLAN already there, which is our system VLAN. So this one is going to be our untrusted VLAN. So it's called untrusted. And in our example, the first port is going to be plugged into the router. So we need to make that a tag port. And the second port is going to go to our wireless access point. So that needs to be tagged. So anytime you want to create a VLAN between routers and switches and access points, anything that's VLAN aware, you need to make those tagged interfaces, because this will allow the VLAN traffic to pass through these interfaces. And these interfaces that are tagged are allowed to carry more than one VLAN. All right, and in my example I did on the website, I just made port 5 like a smart TV just as an example. So we'll just make one port an untrusted VLAN so we can actually test out a wired device that's on our untrusted network. So any of your devices that you plug in, like PC, laptops, game consoles, TVs, NASA's and stuff like that, these will be your untagged ports, because those are your end devices. They don't have to be VLAN aware. So anything that you plug into your device that's not a switch or router or an access point, you can actually put them as the untagged ports. And untagged ports can only belong to one VLAN. So this is what VLAN you want the ports to be on, is your untagged ports, right? Tagged ports is where you want your VLANs to pass through to carry multiple VLANs on a port, which is between all your devices, right? That are VLAN aware. And untagged is just the port you want for your specific devices. I try to reiterate that a few times, just hopefully it's clear when you use untagged versus tagged, because that's always confusing with VLANs. So let's click create. And now we have the untrusted network. And one last thing we got to do, this is a thing, you don't always have to do this on all network switch brands, but for TP-Link, you actually have to go to the port config for port 5, because we added it to the VLAN. When you actually need to set your VLAN ID to 10 and hit apply. If you don't do this, it actually won't properly set that port to the right network. So this is very crucial. All your tag ports can be port 1, so you don't have to change any other ports. It's only the ports where you're plugging your devices in, and you want them to belong to a certain network. So this is a little gotcha step here if you're not careful with the TP-Link switches, because it seems like a lot of other switches, Unify and there's Grandstream and some other brands that I've tried out, they actually automatically put that PIV ID in there for you, which is nice. Even older TP-Link switches, the web interface would fill that PIV ID in based on what VLAN configuration you set. I'm not sure why the new VLAN interface forces you to do that. But I don't really like that, because that's a gotcha. Sometimes it trips me up too. We need to hit save to apply changes, because if you don't hit save on your changes for your switch, when you reboot your switch, you lose everything. You lose all your settings from the last time you hit save. So a lot of switches, you have to apply your changes, because this lets you, the reason they do that is so if you mess your configuration up, you can just reboot your switch and you're not locked out and screwed up, right? So they make you save it one final time to make sure that the changes are, when you know it's a good working state, then you can hit save and your changes will stay. So that's all you actually really need to do to configure VLANs on the network switch. And so it's actually pretty simple to add a single VLAN in there, since we're not doing lag configurations and all kinds of other stuff in here. It's very simple and straightforward. Now what we need to do is plug port 1 into the LAN port of OPNsense. Okay, I plugged my switch in OPNsense. I'm going to set my connection back to automatic DHCP and see what we get here. Okay, apply. And just for good measure, just disconnect, reconnect, because it makes it a little quicker. Okay, so let's go to the console, clear this out. Let's do IPA. As you can see, we have an IP address in the .1 network, which is great. So that means we should be able to go back to our OPNsense, which I have left open. So let's go see if we can go back to the main menu here, and so we can actually log into OPNsense. So now that we're on the dashboard, we know that the client can actually get an IP address on the proper network for the trusted network that we have. And you remember on my example, I can plug into port 3, 4, or 6, 7, and 8 on my 8-port switch, because remember port 5 is in the other network. So I'm going to go ahead and plug into I'm going to open this back up. So I'm going to plug into port 5, and I'm going to see if I get an IP address in that network. All right, so let's check our IP address. And as you can see, I'm in the .10 network here. IP address is 192.168.10.100. So that's one quick way you can actually check if your VLAN configuration is correct, is just by plugging into the other port, because it belongs to the VLAN, which is in technically a different network. So all we have left to do now is configure the wireless access point. So I'm going to plug back into the trusted network, because by default, the wireless access point is going to be in the .1 network. So I want to be in that same network so I can actually configure the Grandstream. So I'm going to go ahead and do that now. Okay, so now I'm plugged back into the trusted network, the LAN network. So I'm going to go to services DHCPv4, and then go to leases. And this will show me all the IP addresses that are on my network. Because the wireless access point gets automatic IP address assigned to it, I don't know what it actually is. So going to the leases page is the easiest way to find that. And you can see it's assigned a .106. So this is my Grand Stream wireless access points. Okay. We gotta accept our warnings because everything has self-signed certificates by default. So the username is going to be admin. And on the bottom of your wireless access point for GrandStream, it actually has the default password. It's nice that they actually have a custom default password for each wireless access point instead of admin, right? So it's kind of some manufacturers do that to make their out-of-the-box experience a little bit more secure in case people forget to change their passwords, right? So I'm going to type that now. Now that I type that in, you'll see there's an option for master or slave because you can actually have wireless access points controlling other wireless access points without having to run separate controller software like Unify. I've noticed that you can control other access points this way, but if you have a network switch, like I have a GrandStream network switch, you can't control more than one device from it. But it's interesting that their wireless access points are set up to where you can control multiple wireless access points from a single one. So that's kind of cool. But if you want to manage switches in addition to that wireless access point, you probably want to install a local controller or use their cloud controller. So let's sign in. Okay, the first time you sign in, you're going to go through a setup wizard. You only have to do this for the first time. But if we go to next, so we're going to set up two wireless networks, one for the trusted network and one for the untrusted network. So by default, it's going to be on the trusted network. So we'll go ahead and set that up. And you'll see here's our wireless access point. We'll just hit next. We want to have it enabled, and we could say, give it a name, whatever you want to call this network. And I'm just going to call H&G LAN because that's our LAN network. And you can leave it on WPA2, or you can do WPA2 or 3/3. You can do both. If so, we can just go ahead and pick that. And pre-share key is just basically your wireless password. And you notice that we already have our device set in our member devices. You just have to make sure that there's a device over here, because if it's on the left-hand side, it won't add it to your device. It'll create the network, but it won't assign it to provision it to your device. So it's important to put this over here. By default, it automatically puts this one in here because it knows you're trying to set this device up. Okay, so now we can just hit complete. And then it's pretty cool. It shows you all the little processes that are getting set up here. And once this is done, you will have a default network set up. All right, so it says we have one access point here and no clients. So this is like a nice little dashboard here. So what we need to do now is we're going to set up a second network for our untrusted network. If we go here, before we do the second network, if you go to edit, you can actually access the more options than the setup provides you. So if you scroll down here, you could do captive portal, client isolation, and there's options for VLANs and stuff like that. So there's a lot more options when you go to edit this. If you have mobile devices in here, I recommend setting the DTIM period to like 3 to save a little bit of battery life on your mobile devices. So that's one thing you might want to do on that one. So we can just go ahead and save that. We can hit apply. Just go ahead and apply those changes. So what we need to do now is set up our second wireless connection by clicking add. And we're going to enter the SSID as HNG. Untrusted. You might not want to call your network untrusted if you're going to broadcast it out, maybe something like guest or something, but it's something more subtle. But I just want to make this clear which network we're setting this up for. I want to enable this SSID. We want to set up the VLAN of 10. So that's all you need to do to set it to a VLAN. It's very simple. You just put the VLAN ID. So security mode, we do WPA 2 and 3, and then we'll do our password here is our pre-shared key. Okay. And then since this is our untrusted network, we might want to enable client isolation. It prevents wireless devices from communicating directly with each other. So it's not a bad idea for an untrusted network to enable that. It's very good for like guest mode and stuff like that when you don't want to trust maybe your guests that are on your network. So we can set the DTIM period to like 3 for wireless battery savings. And before we hit save, I always keep forgetting this, but you have to go to device membership. And we have one available device, which is our current wireless access point. Click that box and then move it over to the member devices. As I mentioned earlier, this is done automatically for your first wireless network if you go through that setup wizard. When we create new SSIDs, we actually have to move that over. It doesn't do it for you automatically. So that's important. Otherwise, it doesn't get applied to your access point. So hit save, then apply. Okay, once the changes are applied successfully, you have both access points here. And let's go ahead and turn off our wired network just so our wireless devices get priority here. And we will check each one of these to see if we get an IP address in the proper network. So I'll turn off the wired connection. Okay, let's connect to that network. Okay, so let's check our IP address and see what network we're in. As you can see, we are in a .1 network with .107 as our address. It's different than our wired device, which was .104. So now we're going to check the other SSID and see what we get. Okay, I'm going to sign into that one. So now let's check our IP address. As you can see, we got a .101, .10.101. So we actually are in the .10 untrusted network. So as you can see, we got an IP address in each network. So we know that both wireless networks are configured properly with OPNsense. And that's all you really need to do to get the basics to get started of separating out your devices. So now we have a trusted network. You can put stuff on your LAN network. You can move your untrusted devices on your untrusted VLAN. So I hope you found this helpful and beneficial in getting started on creating your first VLAN and getting your network set up to kind of get a few devices, like trusted and untrusted devices, separated. And from here, you can actually explore different topics. And as you learn more about OPNsense and firewalls and networking, you just got to keep in mind your architecture as you grow. Just make sure it makes sense and it's reasonable and nothing too crazy and complex, because it doesn't have to be super complex to be still more protected than just a flat network. As you can see, I configured this almost in real time, in less than an hour, right? So just to get a basic network started. So it doesn't have to take forever. It doesn't have to be super complicated. I just want to show you, like, it doesn't take hours and hours. Like my previous guide, I broke it up into 4 videos because it did take 2 to 3 hours because it was a little more involved. If you just want to start off really basic, it doesn't have to take forever. And so until next time, I'll see you guys later.